Hello! Alright, section 2.2. Let's go ahead and change these objectives into essential questions. How do we graph and interpret quantitative data using stem and leaf plots and dot plots? How do we graph and interpret qualitative data using pie charts and Pareto charts? How do we graph and interpret paired data sets using scatter plots and time series? So graphing quantitative data sets, you already have in your notes about stem and leaf plots. So let's talk about the difference between a stem and a leaf. You can see that if I want to make 26, 2 is the stem, 6 is the leaf. That's the stem and leaf there. And then I can also see like, oh, this pairing is 21. Here's what this strategy does. A stem and leaf plot helps you take a big old thing of data and try to figure out what your median is. This way you don't have to write down every single value. If you've got a huge data set, you can break it up. This is like a shorthand sort of thing. So let's go to huge thing of data. We can split this up as either, well, you see 76, we're going to have the stem of 7, leaf of 6. If you have a 3-digit value, you're going to break it up into the stem being 10 and the leaf being 4. So the leaf is always just 1 digit. The stems are the ones that get bigger and bigger. So you see the following on your paper. Go ahead and highlight where the key is at. I think that helps us remember that the leaves need to be 1 digit. Notice how I would also highlight how there are no data entries that are in the 130s. You can also see that it sort of is like a sideways histogram. You can see in the 20s and the 30s, like that's where the majority of our data is. So it quickly organizes your data in numerical order if you need to find the median. It also shows a sideways histogram. All right. Okay. So this is another example that is not in your notes. You can do another version of this. Let's say you don't have a lot of room on your paper and you got to go more vertical with your data. What they're saying is you can produce 2 stems and break up your data, your leaves, into leaves of 0 through 4 and then leaves of 5 through 9. So it's just showing you another visual of how you can do a stem and leaf plot if you're running out of room. Dot plots. You line up the x-axis with every value from your minimum to your maximum. And you just start putting dots above that horizontal axis of how many times this value shows up. Really helps you figure out where's your mode, figures out where's your data concentrated. See, 26 just gets 1 dot. You can also see how 25 shows up twice. 36 shows up twice, so that would be our mode. Going back to this original data, you already have this in your notes. Let's highlight. I can now clearly see 25 shows up 3 times. If it shows up a second time, try to put all the second time dots in the same height, all the 3 times showing up dots at the same. With a pie chart, it's a great visual. People use it all the time. If we have a characteristic, we're breaking up data in characteristics and then we count how many people answered that, then we're going to have to use our relative frequency and put that relative frequency as a central angle like you see in your notes. And to do that, to find your central angle, you're going to have to take your relative frequency. So take your relative frequency, multiply it by 360, because that's how many degrees are within an entire circle. So relative frequency times 360, you're going to get your central angle. You can use a protractor if you're doing this by hand precisely, but whenever we do it on a computer automatically calculates it. After you look at your relative frequency and you multiply every single one of these times 360, these are your angles that you'll be splitting it up. 177.8 is a little less than 180, so we know from geometry that 180 should be a straight shot across, so make it a little less than. If there's not enough room in a pie slice, then you just label it outside. Pareto chart. You've got your categories: accidents, cancer, chronic lower respiratory disease, heart disease, stroke. Those become your x-axis, and then you develop a system on how you want to label your y-axis. Here's our example. Instead of going up 170,000 of tick marks, you could use a label of saying, hey, here's the deaths in thousands, and so on. In a Pareto chart, I want to stress that you always start with the highest category or the highest frequency category, and then you drop off to your in descending order. So that's the other thing about Paretos is order matters. Paired data sets. You've got your scatter plot. We're used to these, where you have a label for the x-axis, you have a label for the y-axis, and these are two quantitative variables. So maybe you're comparing height versus weight on a person's data. Pause the video, read it yourself, and we're looking at this chart. I'm seeing that as a petal length increases, the petal width also increases. So as you move to the right, as the x value increases, see what's going on with the y values. Please write this down as an analysis. So when we construct a time series chart, your x-axis is going to be all the years, and your y-axis is going to be what you're trying to find. We're trying to look for the number of motor vehicle thefts, and so I'm not sure why they have this robberies in thousands, but we are going to look at, okay, in millions, how many burglaries did we have each year, and then describe a trend. You have this picture in your notes, describe the trend, and what we see is it starts in 2011 to 2019, a decrease. All right, thank you for your time.